Hi, here's some worked out solutions to the Algebra 2 first semester review. Okay, so 3x to the 5th to the 3rd, take everything to the 3rd power. So 3 to the 3rd, power to power multiply exponents. 5 times 3 is 15. And then 3 to the 3rd is 27. X to the 15th. On number 2, we're just subtracting. I like to change it to adding the opposite. So I'll change plus negative 2x, and then instead of minus 3s, we'll have plus 3s. So then combine like terms. The s matches up with a 3s, so s plus 3s makes 4s. Negative 3t minus 2t, or negative 3t plus negative 2t, makes negative 5t. There you go. Number 3, multiplying binomials. For this, we need to FOIL. Remember? Multiply the first. 3x times 4x is 12x squared. 3x times negative 5 is negative 15x. Then 2 times 4x is 8x. So plus 8x. And then 2 times negative 5 is negative 10. The middle two terms will have the same variables. So we need to combine like terms. 12x squared minus 7x minus 10. Okay, on number 4, it's basically the same thing. We're going to distribute everything in the first polynomial to every term in the second polynomial. And I'll do it in order. I'll take the x times each, the 3x squared, the 7x, and the negative 1. And I'll get 3x to the 3rd, and then plus 7x squared. Then x times negative 1 is negative x. Then I'm going to take the 3 and multiply that times each of the terms in the second trinomial. 3 times 3x squared is 9x squared. 3 times 7x is plus 21x. 3 times negative 1 is negative 3. Okay, now I have to go through and look for like terms. There's no other x to the 3rd powers, so I'll have x to the 3rd. 7x squared. There's another 9x squared. 7x squared plus 9x squared is 16x squared. Then I have negative x plus 21. So negative 1x plus 21x makes plus 20x. All we have left at the end is just this minus 3. Okay, now, didn't leave much room for number 5, but x minus 3 squared, let's fit it in down here. When you square a binomial, write it out as the two binomials multiplied times each other, and just FOIL it. So you end up with x squared minus 3x, and then minus 3x, and then negative 3 times negative 3 is positive 9, and combine the middle two terms, x squared. Oops, that's still minus 6x plus 9. So x squared minus 6x plus 9. Okay, number 6. 2 plus 5i squared. So we'll write that, 2i plus 5 times 2i plus 5. Remember, I is equal to the square root of negative 1. That's imaginary unit. So I FOIL again. 2i times 5 is 10i. Oops. 2i times 2i. Missed that one. Is 4i squared. Then plus the 10i. And then 5 times 2i is 10i. And then 5 times 5 is 25. Now, I'll rewrite it since that got messy. So 4i squared, 10i plus 10i is 20i, plus 25. Now we're not done because I is equal to square root of negative 1. So I squared is equal to negative 1. So this I squared will replace with negative 1. So that becomes negative 4 plus 20i plus 25. Okay. Now the negative 4 and the 25 can be put together. Negative 4 plus 25 is 21 plus 20i. All right, and that's the answer for number 6. Number 7. Let's finish 7 and 8 real quick. Change the standard form. Standard form is y equals ax squared plus bx plus c. So basically, we need to multiply these two binomials together. So y equals x squared minus x plus 3x minus 1. Combine the middle two terms. Y equals x squared. Negative x plus 3x is 2x minus 1. Okay. And then for number 8, it starts off in vertex form. To change that to standard form, I need to multiply out that binomial squared. So x plus 4 times x plus 4, and then keeping the minus 3 at the end. So x times x is x squared, x times 4 is 4x, 4 times x is another 4x, 4 times 4 is plus 16, and then a minus 3 at the end. Combining all the like terms, x squared plus 8x, 16 minus 3 is 13. Alright, so now that's in standard form. Alright, the rest of the problems I'll do on other videos. So this was 1 through 8. Good luck, bye.